Okay, physical science students, let's go through the Ketterling kola paper. It was due on the 3rd of April. I allowed you to turn it in all the way up until the 10th of April. Now that I've released this video, obviously you can't turn it in, but I do want you to have the correct answers. So go through this video with your Ketterling kola paper. Stop it as you need to so you can fix the things that you got wrong, and make sure you study this for your test. So we'll start at the top up here where it says endothermic. You were supposed to write the definition for endothermic. Anything that is endothermic means it requires heat. Heat has to be put in, endothermic. I have to put heat into a solid in order to turn it into a liquid. So melting would be endothermic. Exothermic means that it releases heat. If you want to get really fancy and start acting like a chemist, a triangle, delta, means heat in chemistry. Now let's start in the solid circle. Particle movement of a solids, they're basically just vibrating, aren't they? They're not moving very much. They're wiggling. I think Mr. Kazi called it jiggling. But the particle movement is slow compared to the others. Spacing is close together. A shape in a solid, I did not want you to tell me what shape this was. I know that's a circle. I wanted you to tell me that the shape of solids are fixed. Doesn't matter what container I put them in, the shape will be fixed. It'll stay the same. Volume is also fixed. Just moving it from one container to another does not change how much space it takes up. And then crystalline, this is where the particles are in an orderly arrangement. And amorphous, there is no pattern. It's not orderly. So that's what I was looking for there. Now, as I leave the solid and go over to the liquid circle, I'm trying to figure out what sort of a process are we dealing with. Well, when it goes from a solid to a liquid, we call that melting. In order for melting to happen, we need to add heat, so we call it endothermic. In the video, I told you the things that go in the hot dog shape are the heat direction of heat, and between the asterisks are going to go the name of the phase change. Some of you put melting point right there. Melting point is a temperature. The name of the phase change is melting. Back to the solid, we see arrows coming out of the solid, and it goes all the way over to the gas. This is, if I'm going from a solid where they're not moving very much to a gas where they're moving very fast, that's going to have to be endothermic. And we call that sublimation. And that was on the Mr. Kazi video as well. Plus, I believe I've talked about that. Now, let's go over to the liquid circle. Let's talk about the particles of a liquid, the movement. They're moving faster than a solid. They're slipping by each other. Remember, they're slipping all around. They're not that far apart, but they're able to move around each other. They're not just vibrating, they're moving around each other, but staying relatively close. Spacing, it's a little more spacing than solid. Not as much as a gas, but a little bit more. Shape, does the shape remain fixed? No. It's a non-fixed shape. If I take a liquid and pour it from a square container to a round container, it's going to take the shape of that container. Volume is fixed. If I have 100 milliliters of water and I pour that 100 milliliters of water into another container, it might take a different shape, but it's still going to be 100 milliliters of water. The volume doesn't change. And surface tension was a tough one. Surface tension is hard to describe in this amount of space. But surface tension, if we remember from our lab with the penny, I told you that the greater the surface tension, the greater the IMF. There's an uneven distribution of IMF on the top of the liquid, the one that's in contact with the air, and the bottom of the liquid, or what's in contact with the liquid below it. But surface tension is just the molecules get a little bit closer together where they touch the air, and that's why water skippers can glide along the top. It's not the same reason that I can walk on water. Oh wait, I can't walk on water. And then viscosity is the resistance to flow. Now, let's go from the liquid back to the solid. When I'm doing this, when I'm going from a liquid to a solid, we call that freezing. Do I need to add heat to get something to freeze, or do I take heat away? I take it out. So it's exothermic. Now, from the liquid, if I follow the liquid out and go to the gas, I am going to have to add heat for that to happen. It's going to be endothermic. And just think about it. Are they moving faster in the liquid phase, in the gas phase, or slower? If I have to have them move faster, then I have to add heat. There's two names for this. It's called vaporization or boiling. Some people also call it evaporation, but evaporation is very specific. It's vaporization or boiling. It's basically going from a liquid to a gas only on the surface. It's much slower than vaporization or boiling because it only happens on the surface. Whereas with boiling, you see it happens throughout the whole liquid. You can see the bubbles coming up from all throughout it. And then if we go from a gas back to the liquid, we're going to be slowing them down. So that's going to be exothermic. And when something goes from a gas to a liquid, we say that it has gone through condensation. It happens when you take something cold out of the refrigerator and then vaporized water particles come in contact with this cold surface, and this cold surface slows these down enough for them to turn into a liquid, and that's what those little droplets of water are on the outside of the cola. It didn't come from inside the cola, it came from the air. It was gaseous water molecules that were slowed down enough to turn into little drops of water. Now let's talk about particles in a gas phase. Movement, very fast. The fastest of all the three main phases of matter, not as fast as plasma. Plasma's faster, but we are only dealing with these three here. Spacing, very far apart. They are moving independently of each other. The intermolecular forces no longer have a say as to what each particle does. Shape, not fixed. It's going to take the shape of whatever you put it in. Volume, there's no volume. It will keep expanding until it, it'll just keep expanding, so not fixed. When we leave, we already did the exothermic condensation. There's another phase change from a gas to a solid directly. This wasn't on here, but I'll add it in. Am I slowing them down? Yes. So it's exothermic, and we call it deposition. That was in the Kazi video, but this wasn't part of your grade, so you don't have to worry about that. So that's how you do the Ketterling cola. Let me give you a bird's eye view of the whole thing. Of course, yours was supposed to be colored, and make sure you get this corrected and study it for the test.